right, Leroy, if you could share your screen with us, please. Okay, good afternoon, everyone. Sorry for that hold up. Welcome to today's webinar on water penetration, resistance, and brick veneer with our wall systems research and development manager, Leroy Danforth. We're delighted. My name is Brian Yansak, and I'm the design studio and events coordinator for Glen-Gery. During the presentation, you will notice the Q&A function at the bottom of your screen. Please feel free to submit any questions throughout the presentation, and they will be answered at its conclusion. Your attendance will be marked, and we ask that you stay on for the duration of the presentation to receive your credit. Everyone attending the duration of the course will be receiving a certificate of completion within the next few business days, and those who provided their AIA number during registration will be submitted for AIA credit as well. If you are participating today but did not register beforehand with your AIA number, please email events@glengery.com. That is events@glengery.com with your information, and I can get you credit. Today's session will also be recorded, and a link for you to access it will be provided within your certificate of completion. I would now like to introduce our speaker today, Leroy Danforth. Leroy is a licensed professional engineer who has provided technical guidance to the building community for more than 20 years. His contributions include a variety of technical articles and publications on brick construction, participation in the development of masonry codes and related standards, and advancing industry knowledge via hundreds of continuing education seminars. Leroy's current work focuses on testing, development, and technical support innovation of non-traditional masonry assemblies. Leroy earned a bachelor's degree in architectural engineering from North Carolina Agricultural and Technical State University, and also holds a master's in construction engineering from the Catholic University of America. And with that, I'll turn it over to you, Leroy.
Sorry, I needed to unmute myself. Thanks, Brian. I hope everyone's having a good afternoon today. Brian, are you able to hear me okay?
Yep, we can hear you.
Okay, great. So before we get into our AIA program, I would like to share a little with you all about Glen-Gery. In case some of you aren't that familiar with us as a company, I would say if you came in a few minutes early, you saw that we are a company that definitely offers a lot of variety. We're probably one of the most versatile brick companies in terms of the wide variety of offerings that we have. One of the things that we also pride ourselves on, though, is our ability not just to provide a product, but to provide solutions as well and technical support. Just to share with you some of the offerings that we have that go a little bit beyond, your traditional brick. There are some imported products that fall under or within our umbrella. This is one of them, which is just it's a long format brick, if you're interested in that kind of a product. We have Venetian glass brick, which is another very distinct offering that you can use as an accent or, really go for something that's special. Our clay coat line, which is a breathable coated brick product that allows you to get true grays, basically anything from the white to black and in between, that are really true grays, things that are very difficult, if not impossible, to get with a natural through body color addition. We are a manufacturer of handmade brick as well, in case you need to have a new building that looks like it's 300 years old. We still have that capability to provide those, one of the very few manufacturers in the United States that still does that. This is another long format brick, but this one is not imported. This is our domestic long format offering, which is the Roman Maximus out of our Sioux City line. We have a distribution agreement with Creative Minds, which is a very high quality manufactured stone product. And then we have our own line of stone that's made right here in Kentucky, and our landmark line as well. So two offerings from the manufactured stone standpoint. We also are a manufacturer of clay pavers. This is another one of our import offerings that really increases the variety that we have with thin bricks. So Feldhaus is a line that we are an exclusive distributor for in the United States, which really increases our thin brick offering. Beyond just the brick and the manufactured stone, we also have our own a couple of systems that we manufacture as well. Two thin brick systems, one called True Bricks, which is a rail system that uses special slotted bricks for an enhanced mechanical engagement, if you're interested in a thin brick system. And then our Thin Tech system as well, which is a panel system for thin brick that incorporates its own drainage chamber as well. So it's a drained type of thin cladding panel. We also have some folks on staff who specialize in accessories. So if you need help with that, everything behind the brick, we can help with those things as well. So please feel free to reach out to us from that standpoint. And this is just a look at a number of the values that we have and we try to incorporate into our work every day. So as far as our AIE program today, the program is copyrighted, but if you would like a copy of the program slides, we are happy to share those with you. Glen-Gery is a registered provider with the AIA Continuing Education System. And as far as the learning objectives today, what we're going to take a look at is, first of all, at the system level. We'll talk about systems that avoid water penetration, which is primarily drainage wall is the system we want to take a look at. We'll talk about the primary elements within a drainage wall. We'll talk about some of the primary factors that affect the durability and water penetration resistance of clay brick veneer. We will review code requirements for all your typical elements that most of these walls share. And then we'll also take a look at construction and workmanship practices, along with some special detailing and what things that we can do from those standpoints to ensure a wall that has optimized water penetration resistance as well. So here we can see just the order that we will address things in. You'll see we have a short introduction here, but before we get to that, I always like to share where you can find this information. Some of you may be trying to scribble notes furiously. I can guarantee you won't be able to keep up. I'm going to throw a ton at you. But a very good resource is the Brick Industry Association's technical notes. Their website is at www.gobrick.com. And from a water penetration standpoint, the 7 series of the technical notes is their primary series on water penetration resistance, deals with it from a general standpoint. All your typical industry recommendations are there. We'll talk a little bit about mortars today. You can find that information in the 8 series. And then the 28 series is BIA's series on specific wall systems, all the different veneer systems. So you can see here they have one technical note for each system that they cover. And in each one of those, you'll find the nuances of each one of those systems. If there happens to be, for example, a recommendation that differs when you have metal stud backing versus when you have wood stud backing, you'll be able to find those things within the appropriate technical note within the series there. So just a little bit of an introduction here. This is the Governor's Palace in Williamsburg, Virginia, and it's a good jumping off point. When we began building with brick in this country, a lot of the construction would have been similar to this, where we had load-bearing masonry walls, 100% solid molded brick, and typically structures that weren't very tall. As time has passed, the way that we build and the way that we try to address water penetration has changed. We know that with these walls, there was no flashing, there were no air spaces. And in some ways, it's a wonder how these walls were able to manage water penetration. But there are some things that we too often forget that they did that we don't always do. Number one is that these structures almost always had sloped roofs. And those sloped roofs almost always had wide eaves or overhangs or projections underneath them, which actually reduced the amount of water that actually ever saw the face of the wall and had an opportunity to make its way inward. Beyond that, of course, we understand that the mass of the wall, the ability to absorb water, store it for a period of time, and then release it through evaporation was something that they took advantage of as well. So we look at those first few elements in resisting water penetration, and we compare to the way that we build today. Number one, we'll see that we build much taller, which leaves a lot more of the building exposed. If we're talking about commercial structures, we very rarely have a sloped roof anymore. Those eaves and overhangs and projections are gone. And in terms of mass and storage capacity for the water, we've gone from walls that were 8 to 12 inches thick to now something that typically would be a maximum of 4 inches. And then the brick themselves aren't 100% solid. They're typically cored, so only 75% solid or somewhere in that range. So we lost a lot of what was available to us in terms of things that help to reduce water penetration or the severity of an exposure. So that brings us back to some of the old detailing and the old measures, and it helps to explain why they did things like this. And by comparison, we can see here, a lot of us think of this as something that's decorative. And certainly it is. It's meant to be appealing to the eye, but that's a little bit of a trick. More than it's decorative, it is functional. You don't have, flat planes here. So this is all about shedding water, and then with the overhang, getting that water away from the surface of the wall below. And even though we may not go to these lengths from an aesthetic standpoint, we can see very often that if we don't do something, that the results typically aren't what we anticipated, or at least not what we're pleased with. So in this case, you can see, just with standard brick at the top of the wall, no slope, lots of joints, very often in a freeze-thaw climate, that the top of that wall will begin to deteriorate. So the primary keys to water penetration resistance, the things that they sort of depend on. Number one are going to be quality products. Number two is going to be proper installation or workmanship along with that product. But the design, the way that the material is designed, the way it is detailed is just as important, if not more important, than either of these. We have standards which ensure, or should ensure, typically ensure, that we're going to have a quality product. When it comes to installation and workmanship with the masonry assembly, obviously that is something that is very, very important. But when we take a look at something like this, and I'll give you just a few moments to look here, just consider. We can see that there's some distress here. We can see that there's some staining here. But when you consider those elements, what's to blame? Is it the product? Is it the installation? Is it the design? Or could it potentially even be maintenance? And very often the answer to that question is not just one thing. It'll be a combination of things. But in this case, there certainly are some things that we could point out. The more joints you have in an element, the easier it is for water to get in, especially when it's near horizontal. When you do have an element like that, as we see here, there should be, a flashing underneath a coping or a cap. That would help to direct any entering water out. And in this case, it looks like a masonry unit here that is probably glazed, which means that once water gets in, it really doesn't have an opportunity to make its way out again. And so it's trapped. If we imagine that there is an 8-inch block in there at the core, then that means that there's no airspace, there's no room for one. So the brick is probably mortared solid against it. All of that material absorbs water, as it wets. And if you get freeze-thaw cycles and that water expands, then potentially you end up with a crack. And once that crack occurs, now all of those compounds that have been dissolved from the prolonged saturation have somewhere that they can make their way out. So there are a lot of things going on here. We will address some of those issues. But just another quick example. This is something, I took this photo in Chicago. It's about maybe half an hour after a drizzle or maybe even a light rain developed. And you can see how the water here is being directed, or it's draining at the joints in the coping, the metal coping here. And that in and of itself is not a problem. What you see here is not a stain, as I mentioned. You can just see it now because the wetting is just beginning. But imagine over time, if you have one area like this where it gets wet more often, or the saturation of the masonry is prolonged, then there is a potential that you could see staining over time, and even, possibly even deterioration similar to this. So we have to consider these things, just for example, a cap or a coping that had an increased slope to the backside of the wall would have been something that may have helped to prevent something like this. So there are, of course, as we consider those factors, the products we choose, the way that we design and detail, the way that they're installed, those are all important components. So if we start at the beginning, the first thing that we should understand, and I think probably we all do, is that we should be designing drainage walls. Just from a performance standpoint, it gives us somewhere that once water enters the wall, we're providing a means for it to make its way out. So the way the drainage wall works, we know that some of the water is going to make its way in through any sort of construction deficiencies, maybe cracks in the mortar, anything that may happen there. Or if nothing else, these assemblies are simply not perfect. Most wall assemblies are not perfect barriers to water. So water can travel down the back face of the brickwork. If it happens to go further in, we know that we have a drainage plane even further behind in the wall where the water can drain. That drainage plane is going to be integrated with our flashing, which is at the bottom of the wall. So that water is collected by the flashing, and that flashing then directs that water to the exterior of the wall through the weep hole. So this is just a look at how a real world example might look, where we have our airspace. In this case, you can see there is a drainage material in here as well. So one of the things that I'll point out here, I think this is probably something that we can all agree on when it comes to a building enclosure wall. What I will add is that I would suggest promote, even when you're doing landscape walls, entrance signs, trash enclosures, those kinds of things, I still try to promote drainage walls with a drainage space in them. And the reason is because typically elements like that, they're very often brick and block. You're not worried about any, conditioned space on the interior or anything like that. But the primary contributor to efflorescence is Portland cement. Of course, concrete block contains Portland cement. And if you put your brick directly in contact with a block or even with a concrete backing or anything that contains Portland cement for that matter, if they're in contact with each other and it's basically exposed on all sides, it's going to get saturated. When it's saturated, those compounds are going into solution. And with a direct path, direct contact, that increases your potential for efflorescence. The other thing is you've got those absorptive materials, they're exposed on all sides. It also means that you have increased the potential for prolonged saturation. So from the standpoint of efflorescence, as well as the standpoint of freeze-thaw potential, the more often it wets, the longer it stays wet, the higher the potential you're going to get freeze-thaw deterioration. So by providing an opportunity for that water to first of all, separating those two masonry elements from each other, and then providing a space for water to drain between them, you're going to promote drainage and drying, and you reduce the potential for any water-related problems, even on a landscape element. And so for that reason, I promote drainage walls even for those. So with that said, most drainage walls are going to have some fairly common or standard elements. So if we take a look at some of those, and I'm just going to start from the sheathing or from the substrate if it happens to be masonry out. Very often we're going to have an air and water barrier there. There will probably be continuous insulation, which is in a water resisting component, but it likely will be there. Of course, we've got our ties or veneer ties that are connecting our veneer to the structural backing. And then we've got our drainage space. Our drainage space, as we see here, can include some sort of mortar collecting or drainage device as well. So as we take a quick look at each one of these, we'll start with the water resistant barriers. And just some quick notes, probably review for most of you. We know that the primary function of the water resistant barrier or the air and water barrier is to protect the sheathing or the substrate from liquid water. It could be air permeable or it could be impermeable, in which case it would be an air barrier. And we've got, simply three types: mechanically attached sheet membranes, self-adhered sheet membranes, spray and fluid applied materials, and then you also have some board materials as well. And in terms of performance, all of these materials can work. They all work a little bit differently. What it takes to make sure that they perform as they are designed and intended is a little bit different. With sheet materials, you want to make sure that they're lapped properly. With spray and fluid applied materials, you have to make sure that where you have gaps in the substrate that they're adhering to, that they're being applied to, that you have proper support, that you have proper transition materials to negotiate those gaps. And if you have board materials, you have to have the joints taped or sealed between them. As I said, all of these can perform adequately. One of the things that I tend to see that makes the biggest difference is what is that material going to be exposed to before it's covered. And from that standpoint, your mechanically attached sheets, if they're going to be subject to a lot of wind, then that can put stress on the fasteners or at the fastening location. Sometimes it gets ripped around those. And if that's the case, then certainly they would need to be repaired or taped in order to continue to have that continuity to resist water penetration. So then we'll take a look at our drainage space. And I'll give you a few moments to think about this here. What does the IBC actually say when it comes to an airspace behind a masonry veneer? Does it say that the airspace has to be at least 1 inch? Does it say that the airspace has to be less than 4.5 inches? Does it say that you can have an airspace that's more than 4.5 inches, but somebody's got to crunch the numbers to make sure that it's okay? Or is it all of the above? So I'll give you just a moment to think about that. And if you're thinking D, all of the above, it means that either one, you're pretty good at test taking strategy. Number two, maybe you've been in one of my seminars before, or number three, maybe it's just something that you've run across or maybe asked or been told at some point. But the answer is D. All of these are in fact true. This is important because if you do have an airspace or a drainage space that's more than 4.5 inches, it means that your tie is subject to some loading that we have to make sure that it's stiff enough to be able to transfer the loads properly. But from a water penetration standpoint, the critical thing is that that drainage space is at least 1 inch. The Brick Industry Association, which is the national authority on brick construction, actually recommends a 2-inch airspace, 2 inches wide for commercial wall assemblies. And the reason is very simple. Even though the code allows a minimum 1-inch airspace, we know that mortar bridges mortar can completely bridge a 1-inch airspace as it gets dropped into that space. Also consider that this is construction. The way that we draw it with a perfect straight line in our drawings is not what happens in the real world. In some cases, the backing wall or the veneer may be a little out or a little in. And so that 1 inch that we put on our details may be a 1/2 inch in some places. So the 2-inch recommendation allows for the construction tolerance. It also, when you have a drainage space that is 2 inches, the mortar cannot bridge. Gravity takes over and it will fall further into the wall at that point. So the drainage space is important because the brickwork itself, it is a term, the reservoir cladding is a terminology that's sometimes used. It does absorb water. And so you don't want that water to be held against the rest of your wall. It also gives that water somewhere to drain. So this is what we want to avoid. Narrow spaces simply are more easily to become blocked with mortar, and that over time can certainly become a problematic issue. And so there are a number of collection devices, either mortar collection devices or devices that prevent mortar from bridging the cavity that can be used. The one on the left is a product that's used at the bottom. And so it keeps the weeps open. It prevents the weeps from being blocked. Notice, if you don't happen to be familiar with these types of products, that it has an offset shape. And you can see that the mortar sits on top of there. If it was flat across the top, then the mortar would all be sitting at one level. And imagine there was just, 3 or 4 inches of mortar straight across the top of that. That could actually dam mortar and prevent it from ever getting to your weeps. And so having some sort of a shape or otherwise being configured to catch mortar at different heights within the wall is something that's important. On the right is a material that would be used full height within the wall. So it actually fills the entire space between the brick and the backing. And that's something that's used in some jobs, not needed for every job, but I would say particularly where you have taller walls with thinner air spaces, that's something to consider to prevent the mortar bridging from occurring. That could have a negative impact on your drainage. And these devices are something that the BIA actually recommends for these walls. So the next element that we'll discuss is our flashing. It's a very important element in the wall. It's, of course, integrated with our water resistive barrier. If you've got a sheet material, it's probably going to lap over the top of your flashing. If you've got a fluid or spray applied material, then you'll probably see something like in the photo here, where there's a turn bar with a sealant joint, and that's how the two are integrated together. But here we can see at the bottom of the space, of the airspace, how it collects the water. It would drain down onto the flashing, and the flashing directs it out of the wall. where there would be weeps. So the critical points for your flashing are at the top of the wall. Top of the wall provides an area that has a really high potential for water to get in, probably the most. So flashing at the top of the wall prevents water from getting in. Flashing at the bottom of the wall gets any water that has made its way in out of the wall. If there's anything that prevents that water from getting to the bottom of the wall, any interruption in your airspace or drainage space, then those are the points where you want to flash. And that's typically going to be at things like your window and door openings. So this is just something that I wanted to point out. Here we see a flexible membrane flashing material. It's not a great photo, but it's a great point. You can see that the flashing is actually a little bit back from the face of the wall. The first thing is that the code actually requires that flashing extend at least to the face of the masonry. And there are some products that the manufacturers recommend that they be held back from the face of the wall. And in that case, what you need to do is to use them in conjunction with a drip edge, a separate drip edge. But in this case, the reason why I like this photo is that you can see, remember that most of the brick, probably about 97% of the brick that's made in the United States is extruded brick, which means it has core holes. And if you hold the flashing back from the face of the wall, what you may actually be doing is ensuring that all the water that you collect gets emptied into the core holes in the brick course below, in which case that would lead to saturation of that course, possibly the courses below, and may result in some staining or some other water-related problems. So remember, the code says always your flashing needs to come at least to the face of the wall. And in this case, where this is a coping or a wall cap, it should actually extend beyond the wall on both sides. So that's what we see in this detail here. This is a coping detail from the BIA's Technical Note 7. A couple of things that I want to point out here in terms of, I guess, what would be preferred or best practice for a coping detail. The first thing is note that even though this is a Brick Industry Association detail, they show a precast or stone coping. And the reason for that is certainly it could be done in brick, but if it was done in brick, it will most likely be a roll-lock type detail. And in that instance, there would be a joint, a head joint, about every 2¼ inches. That's a lot of joints. The more joints you have, the more opportunity for water penetration you have. So precast or stone or cast stone, all of those materials that you can get in 3, 4, 5 foot lengths with very few joints from a water penetration standpoint are definitely preferable for a coping material, even natural stone. Here you can see that there is flashing across the top of the wall underneath the coping in the detail. That is also a code requirement, but it presents a construction problem because that means that there's nothing for that coping to hold on to. It's not bonded to the rest of the masonry there. And so what you can see in the photo on the right is they're actually drilling down through the flashing in order to put a dowel or pin or some sort of connection to actually attach or anchor that coping down. So there are a number of ways to accomplish this. This is another detail with a metal coping that uses a little anchor and pin. Another one here. There are a number of different variations of ways to do this. But having that flashing there is very important from a water penetration standpoint. And again, it's also required by code. Here is a detail with, not a detail, but a photo of how it's sometimes constructed with a flexible membrane if you didn't have a rigid metal flashing. So in this case, I took this photo at the International Masonry Institute's training center. And so this is actually a wall that they use to train the masons and show them how you integrate that flexible flashing with a drip edge, that can go out and extend beyond the wall face. And notice that they have the pins or the dowels there to anchor the coping on the top. So you do have to penetrate your flashing in order to do that. But as long as you seal around that penetration with the appropriate mastic or what have you, you're going to keep more water out of the wall than if you omit that flashing altogether. So sills are similar. Just a couple of points here on the sills. Again, fewer joints is fewer water penetration. The flashing beneath the sill is a required element by code. And I didn't mention this on the coping, but it's no less true there. Note that there is an overhang here. The sill actually overhangs the wall, and there's a little drip cut into the bottom edge of the sill here. Both of those things help to prevent re-entry of the water into the wall. And if for some reason something goes wrong with that flashing detail, those two elements, that overhang and drip, can be very important. They can prevent a lot of water from re-entering the wall. So that's a really quick review of some very simple, common things that can be done to reduce water penetration, or looking at the most common sort of recommendations. So we'll take a little bit of a turn and talk about workmanship here for just a moment. So what we're looking at in the 3 photos here, let me actually go back. So as a mason lays his brick, we know that some of the mortar is going to squeeze out on both sides. He may take his trowel and cut that mortar off. It may even put it right on the edge of the brick there to start to form his mortar joint. Now, if that's all he does, when he puts that next brick up against, slides that next brick against that, if you were to look at it from the top, it would probably look something like what you see in the photo on the left. So we would be expecting, 4 inches of water penetration resistance, or a nominal 4 inches, if that joint were fully filled. But you can see we're getting somewhat less than that, only about an inch, maybe a bit more. If you were to look at that wall from the back, what you would likely see is a void, such as in the middle photo here. And note that there is water actually leaking through. Incompletely filled head joints are the primary way that water makes its way through a veneer. Now, we are talking about a drainage wall assembly. It is best that those joints be solidly filled, but keep in mind that even if they're not all 100% perfect, this is a drainage wall assembly. If we've got a proper airspace, if we've got flashing and water resistant barrier, then it should be able to manage if every one of our joints isn't completely perfect, such as what you see here. Now, in this case, there is absolutely no chance that water is going to make its way through a joint that's filled like that, but that doesn't always happen. Protecting unfinished work is something that's very important. I always like to use the example of Thanksgiving weekend. At that time of the year, we are experiencing cooler weather. Very often cool, and we can get some precipitation. Imagine we get a soaking rain, Thanksgiving weekend. The mason left early on Wednesday. He's not coming back before Monday, and it rains all weekend. That masonry will be 100% completely saturated, more than likely, and it's going to take a while for that masonry to dry out. While that moisture is in there, it's going to take soluble compounds into solution, and we probably won't see them until March or April when things start to dry out. So the number one measure for reducing efflorescence is probably making sure that walls are covered when they're not being worked on, making sure that unfinished work is protected. Making sure that we specify and employ our extreme weather measures, hot weather measures, cold weather measures, those are also important. What they do is ensure that the mortar stays at a temperature or condition that's going to promote the optimum bond with the masonry units. If we don't have good bond between the mortar and the brick, we're not going to have good water penetration resistance. And so making sure in the summer or in hot conditions, making sure that the mortar and the mixing materials are cool, that they don't exceed the temperatures, so that you don't get flash set in the mortar. It makes sure that the mortar gains strength properly. Same is also true for cold weather as well. The joint profiles that we use do matter. Down in the bottom left photo, you can see that is a concave tool joint, which is probably the most common joint that we see. The concave, the V, and the grapevine, particularly the concave and the V, are the most water resistant joints. And that's because, as you can see in that bottom left photo, they compress the mortar. If you look at how smooth that is, it's because it sort of pushed that aggregate to the back and brought more of the cement matrix towards the front of the joint. And that leads to a tighter joint that absorbs less water, has less surface area. So by comparison, one of the designer's favorites, the raked joint, actually does the opposite. The other thing, actually, let me go back, that concave or V joint does is it presses the mortar up against the edges of the brick. It makes a really tight interface so that the water has a limited opportunity to get in between the brick and the mortar. A rake joint, on the other hand, is one that creates a ledge that actually makes the water stop at the top edge of each brick. The way that you strike a rake joint, it actually pulls the mortar away from the edges of the brick and opens up that interface, in addition to roughening the joint. So for those reasons, if you've probably seen and ignored recommendations by the masonry organizations that say don't use rake joints. So these are the reasons why. Can they be used? Have they been used? Yes, but their weather resistance is lower. Some things that can help. Number one, if you're going to use rake joints, at least specify that they be tooled after they're raked. They can be tooled with a flat joiner. That helps at least to give a less absorptive and more water resistant surface. But I will give you another option as well. And that is a joint profile called a weather joint. I think there are some other names for it also. But one of the primary reasons I believe that designers use the rake joint is for the shadow line that it creates. So this is another joint profile that still gives you a shadow line, but from a water penetration resistance standpoint, you now have a slope that's going to shed water. The edge of the lower brick is not exposed anymore. So this is something that's going to perform a lot better. As far as the type of mortar, for typical veneer clay brick masonry construction, the go-to mortar type is actually type N. In most cases, it's going to offer you a slightly better water penetration resistance because it is going to be easier to use. It's going to have less cement and more lime in it than a type S, which is typically used for block work. And the easier it is for the mason to use, the better your joints are going to be filled. Also, the more cement that you have in the mortar, the more it shrinks. And so there's a slightly higher potential for shrinkage cracking. So from the standpoint of workmanship, there are some things related to flashing as well. Anytime that you come to an end of a piece of flashing, there should be an end dam. That's simply where the end of the flashing is turned up, basically so that it kicks the water out at the end rather than it running off the edges and back into the wall again. So some flashing materials, it's pretty easy to form end dams and form corners with. They'll hold their shape pretty well. And there are other materials that don't hold those shapes as well, or they're harder to form in the field. And so for those, consider preformed elements. There are preformed end dams, there are preformed corners. Even if it's a large job and there's just a lot of repetition, just from a quantity standpoint, there's just a lot of corners and everything. Using preformed elements can help from that standpoint also. So take something like this, for example, you know, with lots of these transitions, you're relying on the mason to cut and patch and fold and mastic every one of those and do it perfect in order to prevent water from getting in. It's a lot simpler if he's able to use a preformed element for something like that. As far as flashing materials, you can get some detailed recommendations in BIA's Technical Note 7A, but in general, 3 categories of flashing. One is your rigid metals. They are excellent materials. They will last 100 years, but they tend to be very expensive in comparison with other flashing materials. So that limits the types of projects that they're usually considered feasible for. Next category is composite materials and laminated flashings. This is a good class of materials that works for almost all project types from the standpoint of budget as well as durability. For most buildings, they're going to last for the life of the wall. A lot of them do have some metal in them, which increases their durability, gives them good durability, but it's thin enough that they can be folded and worked in the field. They have to be soldered, but you can use typical mastics and sealants. You can get, you know, preformed corners and end dams for these. One thing to be aware of though, is this is where materials like asphalt coated copper used to live, or does live. Asphalt materials with asphalt are being phased out of flashing. I believe everybody that was making an asphalt flashing material probably now makes an asphalt-free version of that flashing. And that's because there are some compatibility issues between the asphaltic component and some sealants, some insulation materials, some, you know, air barrier materials. So this is something that most manufacturers at this point will have some sort of compatibility chart. They will tell you what kind of materials they're compatible with. This one happens to come from the Air Barrier Association of America, but definitely something to be aware of. All right, third category of flashing materials is your plastic and rubber flashing, sort of your truly flexible flashing materials. There are some materials in this category that I will say proceed with caution. I used to have a big red X. There's always exceptions to the rule, but I would say traditionally there are materials, you know, in this category that tend to degrade. In some cases because they were just very thin. In other cases because they got brittle and cold temperatures or what have you. So there are some materials definitely to have caution with in this category. On the other hand, there are some materials in this category that have worked very well. EPDM, self-adhesive type materials. Those are really good materials in this category. They have performed, you know, adequately. Usually you want to have a material that's in the 30 to 40 mil thickness range is what most people recommend for materials in this category. They do tend to be affected by UV exposure, sunlight. And so very often it's materials in this category that you would not extend past the wall, but that you would use in conjunction with a drip edge, such as you see here. So a lot of us don't actually like to see that silver line going all the way around our building. So if you don't like that turn down drip edge, one that's a bit less conspicuous is to just have a hemmed edge that extends a little bit beyond the wall. Much less in terms of a visual profile versus the traditional, angle drip. And that is something that is considered acceptable by BIA. As far as weeps, they should be placed immediately above the through wall flashing in the same joint. And in terms of the type of weeps that you use, if you're using an open head weep or a vent or louver, those kinds of things, 24 inches is usually the recommended spacing. If you're using a weep tube or a wick, then the recommended spacing would be 16 inches rather than 24. That's because those types of materials don't let the water out as quickly, and they don't tend to let air in, which promotes drying. You can use your weeps. You can put them at the top of the wall as well, in which case they will double, or they can double as vents if you have an open, clear airspace. And that, as I mentioned earlier, promotes drying and reduces the potential for any water-related problems. So if you happen to be using glazed brick, as I mentioned earlier, does not have the ability to evaporate moisture from the face. It can only do that through the joints, or if you're incorporating vents. So glazed brick is the one time when vents are critical. Normal brick veneers, clay brick veneers, have been performing without vents in them for 100 years. They can perform adequately without them, even though they can be beneficial. Glazed brick, different story though. It is recommended that you incorporate vents if you are doing glazed brick. BIA has a technical note on glazed brick and its detailing. For those vents, you can use the same spacing as you do for your weeps, or you can increase it if you like. So BIA's technical note 13 is the one where you can find additional information about glazed brick veneers. So one of the features that we like to use from time to time seems to occur more and more is incorporating some projecting or recessed courses into our masonry, and that helps to add some visual interest. Keep in mind that most of the brick that you're using, again, is cored brick. Those cores are allowed to come as close as 3/4 of an inch to the face. So that means that your practical limit is something less than 3/4 of an inch. And if you want to exceed 3/4 of an inch for those projections or recesses, it means that you need to be specifying that an uncored brick be used. There are some cases where the manufacturer may be able to adjust the coring to accommodate, but in general, the simplest way is to do it with an uncored brick, or to keep those projections recesses less than 3/4 of an inch so that you don't expose core holes and cause a problem there. So water repellent coatings is something that comes up from time to time as far as a measure for increasing water penetration resistance. The general recommendation in the industry would be that for clay brick veneer, okay? So clay brick veneer, we're not talking about single wide structural walls, but clay brick veneer, is that water repellents generally aren't needed or recommended. The way that water repellents work is they reduce absorption. So the first thing that means is that if there are any construction deficiencies in the wall, that the water repellent isn't going to overcome those. The types of water repellents that are typically recommended are breathable penetrating types like silanes and siloxanes. And they don't fill the pores of the masonry. They don't bridge or seal gaps or anything like that. So say, for instance, you had an incompletely filled head joint. If you apply a water repellent, you still have an incompletely filled head joint. There's still a hole in the wall. That water repellent doesn't help you from that standpoint. What they do is reduce absorption. But I mentioned to you that 97 or so percent of brick that is made in the United States is extruded brick. Extruded brick very often has low absorptions already. So if there is a water issue, consider that, for example, if water is getting to the interior of the building, that means that you have a failure on multiple levels. It's not that the brick is absorbing too much water, which is the only issue really that a water repellent would solve. It's that the flashing detail isn't working, or that, maybe there's a puncture or a tear. The water resistive barrier may have a deficiency in it. The drainage space isn't working. The water isn't draining properly. All of those things, or, would have to happen in order for water to get into the interior. So in general, my point is that if you have a water penetration problem, usually the most effective solution is going to be something else. There are some cases, some conditions where a water repellent is exactly the right fix, but it's not the general go-to sort of works for everything solution that some people tend to believe. BIA also has a technical note on clear coatings. It's their technical note 6A, and so you can go there for some additional guidance on the proper use and selection of water repellent or clear coatings for brick masonry. So, quick summary here. Choose products and details that minimize wetting where possible. That's the first thing that we can do, is try to minimize wetting. Keep the water on the outside by using materials or designing so that we have fewer joints, which provide an opportunity for water to get in. Sloping for positive drainage. Slope, there's good slope and there's bad slope. But make sure that if something is sloped, which is generally a good idea if you need it at the top of a horizontal element, that it's sloping in the right direction, that there's enough slope. And then things like overhangs, can be helpful as well. Making use of effective drainage spaces. Number one, that's making sure that our drainage spaces are the proper width, making sure that they are, the minimums that are required by code or recommended by industry. And if we need to, adding those mortar collecting devices or drainage materials that are going to help us ensure that those drainage spaces perform the way that we intend them to. Specifying measures that promote water resistance. Looks like that's an unfinished slide. What did I have in mind there? I'm sorry, I can't remember what I was supposed to have there. Specify measures that promote water resistance. Maybe it will come to me. But the other thing is that help is available. I've made a lot of mention of BIA's technical notes, and I just realized I had an image. I thought, well, I believe I sourced them all. The International Masonry Institute is another really good resource, especially from the detailing standpoint. They have a web detailing series that is a bunch of, isometric, like SketchUp drawings. You can download them and incorporate them into your own models from their websites. And so they're a good resource as well. So with that, that concludes the AIA portion of the program, and I will stick around for a few minutes and ask questions. I see that there are a few in the Q&A here. All right, so first question was, do we manufacture brick matching? I think this is. Matching brick is can be tough. If you're looking for a brick match, first thing I would recommend is talk to your local distributor. Your distributors have the best idea of what's available from your manufacturers. Usually what we're going to try to do is find the closest thing that we already make. But if you work with a distributor, they're going to have different lines from different manufacturers. And even if Glen-Gery doesn't make one that's, say, a perfect match, your distributor will know if, someone else does make something that's closer. But it's hard with extruded brick if you're not making a large run to try to match something. Sometimes it works out, but usually it's going to be limited to when there's a large run of material. Okay, the next one I see. Matching 52 and 53 DD with very less water absorption for the use of historic building. I'm trying to see if that is related to the one before it. That is one. Let me give everyone my my email address. It's simply Leroy, Leroy, .Danforth, DAN as in Nancy, F as in Frank, ORTH. So Leroy.Danforth at Glen-Gery.com. And I'm not sure about this 52DD and 53DD matching question, but if you want to shoot me an email, I will do my best to answer that or get you in contact with the person who can best answer it. All right. So there's a question here from Jim. Does Glen-Gery offer a paintable brick? And what are your comments regarding older brick buildings that are painted, even though the brick isn't really meant for paint? Okay, so BIA has a technical note 6, which is on painting brick masonry. And I believe that it actually either just got revised or will be revised very soon. Do we offer a paintable brick? I am not certain. I know that there are brick that we have sold as quote unquote painters before. I don't know if there's a particular, like if you look on our website, I don't think there's anything that's marketed as a painter brick. But definitely get in contact with our distributors. That's something that they can help you with. They can talk to our sales managers, and if there is something specifically that would be good for a painter, they can let you know what that is right now at this moment. But all brick can be painted. In general, I would say the industry does not recommend painting brick, and the primary reason is that paint is a coating. Brick is a permeable material. And when you paint brick, we all know anything you paint is going to get painted again. And each time you paint the brick, you further reduce the ability for water vapor to move in and out. You reduce the ability for the wall to breathe. Now, there's two ways of looking at that. You put enough coats of paint on something, water never makes its way in. The flip side of that coin, though, is if you have a construction deficiency somewhere else and the water is already in the wall, then it means that it can't get out. And that's where you sometimes end up with problems. So it is possible to paint brick. There are a number of paints out there right now that if you do paint, they have a high enough water vapor transmission that it doesn't cause problems. But the issue is it's going to get painted again. And over time, the more layers of paint you add, it tends to eventually end up with a problem. Okay, the next one. How you recommend to provide drainage wall in a 12-inch thick load-bearing wall which has water infiltration issues for a long time? That is a question that I'm afraid I won't be able to address here. Definitely some more information needed, but if you want to reach out to me, I can, that's definitely something I can try and provide some guidance on. Question from Michael. While a 2-inch airspace may be recommended, how does a 2-inch airspace impact NFPA 285 compliance? That is an excellent question. Most often what happens is that when you choose your insulation product and you look at their NFPA documentation for it, for NFPA 285, usually what they will do is they will run they'll run the test with the widest airspace that they think they'll be able to pass with. And they'll do that with the understanding that anything less would have, less of a contribution to fire, and that would be okay. So you basically try to run your test with what you think the maximum airspace will be that you will pass. But you definitely need to look at your documentation. If the documentation says, that it's okay for brick veneer with a 1-inch airspace with whatever the rest of the assembly is, and it doesn't say 2 inches, then you're absolutely right. That would be a case where you would need to look for some additional documentation, or you might have to change your assembly in order to accommodate that 2-inch airspace. So I think that probably satisfactorily answers the question. If not, then please type another question in the chat. All right, how do you recommend provide flashing details at masonry openings like windows, doors, and louvers for cavity wall drainage to avoid water infiltrations, and from construction point of view and future maintenance point of view? So the first answer I would have to that question would be to, I would refer to the Air Barrier Association of America as a reference. There is also a guide, a standard guide in ASTM, I believe, for flashing or installation of windows and doors. So I would look to resources like that. It's become pretty standardized at this point. The window and door manufacturers, even, a lot of them have very good details, recommended details that are specific for their products, the way that they prefer them to be done. So that's another resource that you can look at. So I think that would be my go-tos. People such as myself, can also be helpful from that standpoint. But that's where I would start, would be the Air Barrier Association of America and the window and door manufacturers themselves. But, even things like the, BIA, IMI, they have some standard details for flashing at doors and windows and so on as well. Okay, the next one, what is the price difference between 75% solid masonry and 100% solid masonry? That is one that I won't be able to address simply because I'm a technical guy. I don't sell anything, so I'm not as familiar with the prices as others are. But that's definitely something that your local distributor can help you with, or if you want to get in contact with one of the Glen-Gery sales managers, they can help you with a question like that. But unfortunately, that's not one that I'm able to answer for you. Also, okay, is the type of mortar important for considering water infiltration issues? It is important, but the two types of mortar that are typically used for masonry are going to be type N and type S. Either one of them is acceptable for clay brick veneer construction. As I mentioned during the talk, I believe that type N in most instances is preferred, but there are also some cases, for example, a brick with an IRA that is very low. Those you can actually get better bond with a type S mortar rather than a type N mortar. That is the exception rather than the rule. But if you look at BIA's recommendations on mortar types, you'll see that either type N or type S are acceptable for clay brick veneer. It would be unusual to really see anything other than type N or type S. That's primarily what you'll find if you're trying to buy mortar in a bag. Type M is it would be unusual for type M to show up on a job and actually be used in a veneer. So either one of them is acceptable. When you get into the weeds, you can get into some nuances of conditions where one is better than the other. Like I said, I think in general, type N is better for most circumstances, but there are some where S is actually preferable. Okay, so question from Mike. Clear coats. What about systems like surface applied silicone coatings that incorporate sealing gaps, voids? What are your thoughts on those? Also a good question. The reason that the industry primarily promotes, and let me say this as well, I don't know if I mentioned this, my guidance related to clear coatings, I think I said it, but if not, I want to make sure I say it now, was related to new masonry, okay? So for new clay brick masonry, there is typically no reason to apply a coating to it. It's just not needed. Now, if there is a water penetration issue, if we're talking about existing masonry, that changes the ball game a little bit. But your question is, what about stuff that I'm going to classify it this way: film formers, stuff that does bridge and seal and fill gaps. Usually penetrating breathable materials are preferred because they are more like the masonry itself, or leave the masonry in the same condition that it was already in which case it breathes. The problem with a film former is that it can potentially trap water in. If water is getting into the wall, some other means besides through the surface of the wall, the exterior surface of the wall. It's getting in at a roof, it's getting in at a window head, it's getting in somewhere else. Then now potentially that water can get trapped behind a film forming coating. So again, BIA's Technical Note 6A is one that talks more at length about that. But that's why generally breathable, penetrating coatings are preferred, is because they don't have that additional potential to cause a problem that doesn't currently exist. So I have a question from Eric here. I've exposed metal window head flashing that wants to match the aluminum curtain wall finish. What's the best material, as aluminum is not recommended for through wall flashing? I am not certain. You are absolutely right. Aluminum can be corroded by the alkalis in fresh mortar. And so that's true. Aluminum is not recommended for through wall flashing. I don't know if your aluminum for your curtain wall, if it has a color, but it is possible to, and I'm sorry, I'm not a metals guy. So I don't know what the best answer is for that. But the other thing is that, the aluminum, if it's coated, those coatings help to protect it against the alkalis as well. So even though we wouldn't recommend the aluminum as a flashing, particularly if it has a color or a finish to it, then that would be, one way that you could potentially match something to it. So I have a question. If the different types of brick types are used in rows, the upper brick sits slightly recessed in relation to the lower bricks. Would there have to be flashing in between, or would you just select a weathered joint? So I'm just rereading this to try to digest it and make sure that I understand. Okay, so I think I get it. If you have like a recessed, let's say you have a recess or reveal course. I think I'm understanding. If you have a reveal course, for example, would you need to put flashing in there, or could you just do a weathered joint? I've seen it done both ways. And I would say one of the things it depends on would be what the distance or how much recess there is in between the two. Also, what type of exposure it has. If it's in Florida or Arizona, I might consider it differently than if it's in the Northeast somewhere. But if it's relatively minor, let's say course, so recess course, still the same thing. So on that bottom edge, it's more likely it wouldn't even be called a weathered joint. It would just be they would do they call it a mortar wash. But that certainly is something that could be done there. Flashing, I have seen less often, but in cases where that recess is greater, I have seen and even have recommended flashing in some cases, particularly if you get near that 3/4 of an inch, that mark where the potentially the core holes would be exposed. Then certainly in that case, I would recommend a flashing there. Okay, so question from Doug. After a week of rain, my neighbor's brick home always has very wet brick directly underneath the large double hung window with a stone sill, about 5 feet wide by 5 feet long. This exists when all the other brick on the home is dry. What may be happening at this window? If I had to guess, I would guess that window doesn't have any flashing underneath the sill. We all know that sills get wet. They see a lot of water. So all of that brick, if there's no flashing underneath that sill, which is not unusual in residential construction, if there's no water underneath that sill, then all the water that hits that sill saturates the brickwork underneath it. And in that case, it's going to take it a while to dry out. So that would be my guess. That has been one of the reasons in my experience that you do see the area below the sill that stays or saturated for a longer period of time. It's because there's no flashing there to kick the water out. Is there a technical note regarding the NFPA 285 and air cavities on the BIA website? I don't believe there is a technical note. They do have other series of technical documents on their website. I believe that they may have addressed NFPA 285 in one of those. If you want to shoot me an email on that, I'd be happy to reach out to them and see what they have. Otherwise, what I would do is If you go to their website at www.gobrick.com, there is a section called Read and Research, I believe, where they have all of their different series of documents. There might be something there on, they may have a brick brief on a topic, or even a builder note or something on the topic, but I'm not certain whether they do or not. That is the last question that I see. So I'll wait a couple of moments to see if any others come in. And meanwhile, Brian, if you're there, I'll kick it back over to you.
Thanks, Leroy. Looks like no other questions are coming in on my end either. Just a reminder about our next webinar on manufactured stone on Wednesday, March 10th at 12 p.m. CST and 1 p.m. EST. Thank you for joining today. And as I said earlier, you will be receiving your certificate of completion by the end of this week.
Thank you, Brian. Everyone have a good afternoon.